Welcome to another exciting episode of Physics During the Coronavirus Scare. Today I am just doing a short video for demonstration purposes. I don't know that this would have been a very good demonstration in the class because what I'm about to do is on a very small scale, and I don't have a document camera in class to use, although we may be getting one soon. But nevertheless, since we don't have in-person meetings, I really wanted to do some sort of a demo, and so this is what I've come up with. This next course is supposed to be the lecture about current carrying conductors in the presence of a magnetic field. So let's bring the camera in a little closer, and we'll see what it is that I have set up for our demo. Alright, I would like to explain the setup before we do the demonstration. What I have here is a pair of rails which are mounted, and then a magnet in between the two rails, and I have a couple of wires which are connected, as it turns out, to my Pasco 850 interface. Alright. And then I have a magnet, a simple horseshoe magnet present here. And so I have a magnetic field. I have, if I turn it on, a current that cannot complete unless I add this little round piece of wire between the two rails. I can put the piece of wire here between the two rails. You see it's at rest. And if I were to turn on the machine, then I should have some amount of current flow through the wire. I should have some magnetic field. And if I do the direction of the current cross with the direction of the magnetic field, I get some force in this direction, as it turns out. And so when I turn on the voltage, and it's just a simple DC voltage here. Let's see if we can zoom in and read it. Not terribly well. You can see that it is a DC voltage. This says 3 volts, and I've put some voltage limit to it. So let's turn it on and see what happens. Alright, I am going to just simply click a button to turn the current on. And when I do that, it rolls. It rolls in the direction that we said it should roll in. Whoops. Alright, and now I show you that the mouse is not attached to anything, so this is not a vibration. Just puts some current on it and gets a force from the magnetic field. Now there's a couple things that we can do to expand on this demonstration. Oops. One of them is that we can change the voltage. So this was at 3 volts. Let's see what happens if I go to 6 volts. Alright, ready? Okay, and maybe we can go to 12 volts. And one more repeat. And what else could we do? We could reverse the direction. So I'm going to go back to 3 volts. We can reverse the 2 wires. So they're like this and this instead. I'll put this in the same location. Now if I turn it on, it goes in the other direction. Got to repeat it to make sure. Whoop. suppose there is one other thing that we could do that is interesting. And that is that we could not apply a DC voltage. We could apply an AC voltage. This is now 2 hertz. So I'm going to turn on an AC signal to it. Is 2 hertz and 4 volt amplitude. And let's see what we get here. So that's what we have for today's demo. You see that if I add some current to the wire, that there is a force upon the wire that causes it to move. And in fact, there is, I would argue, maybe some torque on it because it in fact rolls. So we could figure out if there's a frictional effect that causes it to roll, or whether it's just the force from the magnetic field itself acting on the current carrying wire. So that's it for today's demo, and hope you enjoyed it.